Okay, welcome to level 2 formula writing for the summer assignment. And we're going to be doing D block atoms or ions and polyatomic ions as far as our formula writing. So everything that we're going to be doing here is going to be ionic because there's going to be a positive charge and negative charge. We are still going to use some of the stuff that we used in level 1, which is the periodic table where we have the metals and the non-metals. And we are also going to use the charges, because if it's ionic, it's going to have a positive charge and a negative charge. And then finally, we're going to use something you get off of your summer assignment, where it has a list of these common ions that we're going to use. Now, as you can see, some of them are just elements, but most of them are what we call polyatomic. And poly meaning many, atomic meaning atoms, and an ion meaning charge, which in other words is just a group of atoms. In this case, ammonium has 1 nitrogen, 4 hydrogens, and as a group, they're going to take on a positive 1 charge. And all of these kind of work the same way. For example, this group for sulfate is 1 sulfur and 4 oxygens, and as a group, they take on a negative 2 charge. So let's jump right into it and do level 2 formula writing. Okay, so the first thing that we have is what we call the old phase of the D block. Okay, and when we look at D block atoms, we're talking about this group right here, groups 3 through 12. And if I pull out my other periodic table, you can see groups 3 through 12, there's no charge. And the reason for that is that these atoms are kind of special, and they will take on more than 1 type of charge, with the exception of copper, which is a positive 1, zinc, which is a positive 2, and cadmium, that's a positive 2. But all the other ones, for example, you have iron right here, it can be a positive 2 or a positive 3. They take on various charges, okay? And we have the new phase of dealing with that with the Roman numerals that we learned in level 1. But we also have this old phase, and this old phase just hasn't been phased out enough for me to feel comfortable with you guys not knowing that information. So today we're going to talk about the old phase for the D block, and then also polyatomic ions. So when you have the old phase, what you have is an IC or OUS ending. Now, there's only a couple of them that are still really prevalent, and those are the ones that I have here at the bottom. We got cupric, which is a positive 2 charge. We have ferric, which is a positive 3 charge. And we have plumbic, which is a positive 4 charge. There are others, however, these are probably the ones that are most prominent today. So those are the only ones I'm going to make you memorize. Now, I also mentioned that it could have an OUS ending. And if you look on this sheet, there's nothing up here with an OUS ending. And that's because we're going to use a concept to change these IC endings to OUS endings. And let's kind of read what we have here in our notes. We got a little chart, okay? And what it says is if you have a D block ion that is a positive 2 charge when it's an IC, well, when it's an OUS, all you do is drop the charge by 1. So instead of a positive 2, it's a positive 1. We do the same thing for our positive 3 old phase ions. If the IC is positive 3, then when we change the ending to OUS, we make it a positive 2. And the only thing that's a little irregular is our positive 4s. They don't drop down 1, they're going to drop down 2, so they're going to go from positive 4 to positive 2. So what does that mean for the 3 that we have here? Okay, what it means is if cupric is a positive 2, then cuprous with an OUS ending is going to be a positive 1. Ferric, which is a positive 3, well, ferrous with the OUS ending is then going to be a positive 2 ion. And then finally, plumbic, if we change it to plumbus, we're going to change a positive 4 to a positive 2. And that's all there really is for D block ions. So let's kind of do a couple of these molecules, okay, that or formula writing. So the first one we have is ferric chloride. Okay, so the first thing I'm going to do is I'm going to try to figure out the positive charge and the negative charge. Well, ferric, that's one that we've memorized. Ferric tells me that it's a positive 3. So I'm gonna write down +3 right here. And I gotta look up the negative ion, chloride, and this is the same thing that we did in level 1. So if this doesn't sound right, you might wanna go back to level 1 formula writing, but I look up chlorine and it's a -1 charge. So I'm gonna put chlorine as a -1 charge. And like I said, we're just gonna help the loser until there's a tie, just like we did with level 1. It's gonna take 3 -1 ions to cancel out 1 +3 ion. So the formula for ferric chloride is gonna be FeCl3. And that's how you handle D block with the old phase of formula writing. Now, if it was ferrous, remember, okay, if ferric is a +3, then ferrous is a +2. And that's the only thing that changes between ferric and ferrous is the charge. It changes from +3 to +2. Of course, if it's still with chloride, well, we will only need 2 of them to cancel out the +2 charge. So ferrous chloride is gonna be FeCl2. And we're gonna do that here with cupric and cuprous. So I'm gonna get out my flashcard. Cupric is a +2 charge. Oxide, I gotta look up my oxygen. My oxygen's a -2 charge. Oh, look, this works out perfectly in a 1-to-1 ratio. A +2 will cancel out a -2. So the formula is simply CuO, okay? Now, if it was cuprous, remember we gotta drop the charge by 1. So instead of a +2, it's going to be a +1. And if it's still with oxygen, which is a -2, then we're gonna need 2 of the cuprous ions to cancel out the -2 charge of oxygen, and the formula becomes Cu2O. So that's how you handle D block atoms, okay? Doing it the old phase with this IC and OUS ending instead of dealing with Roman numerals like we did with level 1 formula writing. Okay, so the next group is going to be our polyatomic ions. And like I said at the very beginning of the video, a polyatomic ion is just a group of atoms that collectively take on a single charge. Okay, so let's take a look at our first one. It's going to be barium nitrate. Okay, well, the barium is not polyatomic. That's just an element. So I'm going to look up barium, which is Ba, and it's a +2 charge. So that's my positive ion. But then I have to look up nitrate. And I look up here, nitrate is NO3 with a -1 charge. So I'm gonna write that down, NO3 with a -1 charge. And as you can see, I gotta help the loser. I got +2 charge versus a -1 charge. So you help the loser until there's a tie. So I do a whole nother group of this polyatomic ion called nitrate. And it's going to take 2 of these groups of NO3 to cancel out the +2 charge of barium. Now, there's a little star asterisk right here. It says make sure to use parentheses if using more than 1 polyatomic ion. I'm going to show you why that's so important. So if I did barium and then I simply said, hey, 2 nitrates, it almost looks like there's 32 oxygens, and that's not the case. There's only 6. So when we use these polyatomic ions more than once, we have to put them in parentheses. And then on the outside of the parentheses tells you how many of those groups you use. So this is really saying, hey, there's 2 nitrogens and 6 oxygens, because there are 2 nitrogens and 6 oxygens, okay? And we would never write it as N2O6. I've seen students do that before. We don't do that. We just put the group of our polyatomic ion in parentheses, and then after the parentheses, how many of those polyatomic ions that you actually used. Okay. All right, so let's move on to the next one, radium acetate. Okay, so radium is Ra, and it's a +2 charge. And we have acetate. Now that's a big one. Okay, right here's acetate. C2H3O2 with a -1 charge. C2H3O2 with a -1 charge. And then it just becomes regular formula writing, just like you did in level 1. Okay, so you help the loser, which is going to be the acetate. And 2 -1s will cancel out the +2. So it's going to be Ra. And remember, since we use the group more than once, we got to put it in parentheses, C2H3O2 in parentheses, and we used it 2 times. Next one's rubidium carbonate. Rubidium is a +1. Carbonate, we're going to look it up. Of course, you're going to have these memorized when school starts, so you won't be looking this up. I'm just trying to do this for instructional purposes. But carbonate is CO3 with a -2 charge. CO3 with a -2 charge. And as you can see, we need another rubidium. We need 2 of the +1s to cancel out the -2. Now, when I write this formula, Rb2, but I only used 1 carbonate, so I am not going to use parentheses. In fact, if you do use parentheses, it would be considered incorrect. So you only use parentheses if you're using more than 1 polyatomic ion. The next one is magnesium hydroxide. Magnesium is a +2. And hydroxide is OH with a -1 charge. And it's a +2 versus -1, so we help the loser until there's a tie. We need 2 of these -1s to cancel out the +2. So it's going to be Mg. Now we use this group more than once, so once again, we are going to use the parenthesis, okay? If you didn't, and you wrote it like this, MgOH2, it looks like there's just 2 hydrogens, but there's also 2 oxygens, and that's why it's so important that we use those parentheses when using it more than once. All right, next one we got ammonium phosphate. Now, ammonium is not an element like all these others. It's actually a polyatomic ion as well. So ammonium, one that you memorize, is going to be a group of atoms that consists of 1 nitrogen and 4 hydrogens that take on a +1 charge. 1 nitrogen, 4 hydrogens that take on a +1 charge. And we have a second polyatomic ion called phosphate, which is 1 phosphorus, 4 oxygens that take on a -3 charge. So 1 phosphorus, 4 oxygen that take on a -3 charge. And it just works like all our others, okay? We just got to help the loser. And we're going to have to help it more than once until there's a tie. It's going to take 3 ammoniums to cancel out the charge of the phosphate. Okay, so 3 +1s to cancel out 1 -3. Now we use that ammonium 3 times, so we're putting it in parentheses. However, we only use the phosphate 1 time, and we are not using parentheses. And of course, we can work this in reverse, okay? Now there has to be a little bit more identification here. Okay, so if we're working reverse, okay, the first thing we need to do is say, okay, we got iron bromide, but remember, iron is in the D block, okay? So we have to either use a Roman numeral or we have to use the old phase. Roman numerals were for level 1, and we're doing level 2 right now, so we're gonna use the old phase. And what I see here is we got 1 iron and 3 bromines. And I gotta figure out what the charge on the iron's going to be. So I look up my bromides, they're -1s. So if I have 3 -1s, then the iron here has to be the +3 version, and the +3 version is going to be ferric. So we're gonna name this ferric bromide. So it's exactly the reverse thinking of doing this, but you really have to identify what type of charge you have. Same thing for FeBr2. Well, if I only have 2 Brs, each at a -1, then the iron has to be the +2 version, and it's no longer ferric, it's going to be ferrous bromide. Next one we have, okay, we got lithium. Okay, so that's going to be the positive ion. That's easy because it's not D block. It's just in, the one that we have trends for. So our lithium's right here. And what is an SO4? So I got to look this up. Where's an SO4? And if I look this up, I'm going to find it right here. Okay, SO4, and that's going to be called sulfate. So this is simply lithium sulfate. NH4, look it up. That's going to be the ammonium. And then CO3, that's going to be the carbonate, which is right here. So this is simply ammonium carbonate. And lastly, we got Ca, which is right here, which is just our calcium. And we got C2H3O2. That looks like a polyatomic ion. That's going to be acetate. And as you can see, I didn't use di, tri, or tetra. Those are for covalent compounds. These are all things that have charges. Okay, everything on this list has a charge. So everything here in level 2 is ionic. Okay, and when you have ionic compounds, there's no prefixes. So I really hope all of this helped. I would move on to the homework and see how you do. You can check your answers and then move on to level 3 when it's all mastered. So like I said, I hope this helps. And when you have mastered this, move on to level 3.